is going to join. But before that, I'll quickly set the context, the format of what we are going to do. So for the first 10 minutes, Sid will start giving a quick introduction about Finternet, what it is, why it is, what we are trying to do. Then Apur will take care here. He will share the quick architecture, technical architecture about Finternet. We are also going to give a demo of a cross-border money transaction use case that these guys have pulled off in last probably couple of weeks. They have published a white paper as well, so we are going to talk about that a little bit. Then we are going to quickly put in, I'll just share a quick context on how Ethereum fit into the larger scheme of things. And after this, like probably we'll spend around 20 minutes by this, we'll be done. And then we wanna break into more of a jam session about specific problem statements we have, which will be around verified credentials, proofs, and these kind of things. Sid, can you hear us?
Hello, I can.
Cool. So I'll give it to Sid. He will quickly give an introduction about Finternet, and then as I speak, like we'll move ahead. Go ahead, Sid.
Should I just share my? There's a bit of an echo that's coming in.
It should be fine now.
Okay, and should I just share my screen from Meet? Is that okay?
Can everyone hear well?
Sorry, Rohit.
Yeah, I think you can start. We can hear you well now.
Okay, perfect. Let me just share my screen. Are you able to see the screen?
We can hear you. We can hear and
Yeah,
see you also.
you can see it. Okay, perfect. Well, let's dive in then. So, thank you all for joining in this afternoon. Really appreciate it, and looking forward to. Unfortunately, I couldn't be there in person. I'm in the US right now, but looking forward to how this workshop goes, and many of the community members, Rohit, Apur, Sheikh, and many others are there in person. So, looking forward to hear the various ideas that come through this workshop. What I will do in this presentation, I'll keep it rather brief, is just give you a quick overview on what the Finternet is and our context for how we arrived at this. This was part of a paper that we published in April of this year. And the real intent was, if I had to summarize the way we've been building financial infrastructure, it's essentially every time we build a new car in the financial system, we build a new road. And what that means is you have different types of settlement systems. We'd often build one for P2P transactions between individuals. Then you'll build a separate system for government to person payments. You build a separate system for securities. And then in many cases, when you want to make some assets transactable like property, there's not much infrastructure that's there. And so as you can imagine, if you have all these different roads, interconnecting them is high transaction cost, high silo, has a lot of silos, and that limits the reach, and that results in a lot of the fragmentation and problems that we see today. And as we were looking at this, what we realized is technology often starts off very purpose specific, right? And so for those of you in India, you may be familiar with the work that's happened through UPI, which is a purpose specific payment system, and then the open finance work through account aggregator, which is another purpose specific data sharing system. But actually, if you ask more first principle questions, why couldn't these be built on top of each other? Why couldn't you enable read write together? Why did you build two parallel systems? You start getting into some interesting questions, and that's really the journey we went into. And if you think about it, the early days of the internet, you see the same effects playing out, right? So you had purpose-specific networks. You would have companies providing you the protocols, networking stack, software front end, client side, back end, server side, in some sense, for them, pre the actual client server architecture coming together. But you'd have sort of these very closed loop systems playing out, and then you'd have similar arguments saying, how could we interconnect, how could we bridge onto a broader system because of privacy, security, and other control mechanisms. But societies need to transact increase so much, our need to communicate with each other increase so much, through the development of internet protocols like TCP/IP and the packet structure and others. We bridged onto a public internet, and so now I'm able to dial in using a completely different software stack from where I'm at versus the laptop that's plugged in there. Yet this works in an interoperable manner. Sorry. And we saw the same thing play out even with smartphones, right? You had individual purpose specific technologies, a DSLR camera, a mic, typewriter, and obviously, these were not programmable. They solved use cases in their own domain. But when you could bring them together and then unify them and open them to a larger entrepreneurial ecosystem, we unlocked innovation at societal scale. And our view was the financial system is at a similar threshold. If we look at the developments that are happening both in the traditional financial system, but also the more cryptographic advances that are taking place. And so that's when we came up with the Finternet, saying, what if we imagined a world where one, individuals and businesses had complete agency and control over any asset, and these assets could be regulated assets like different forms of money. It could be securities. It could be registered assets like physical property or a vehicle, anything that has a registrar attached to it. It could be attested assets like gold, anything that has third party ratings or accreditations attached, or user controlled assets like digital content, music, etc. And fundamentally, all of us over a period of our life will have assets that span these different categories. But today, the way you transact with them ends up being very fragmented. You go to a brand somewhere, multiple portals, all of that drama plays out. How do we give that control, give that agency back to all of us was an essential part of the internet. And our view was, if you think about it in the physical world, right? Let's say I'm where I'm at in the US, and I had to, let's say, transfer a dollar to Rohit on the other side. Now imagine Rohit was next to me. I could just give him a dollar bill, and that's it. Rohit can look at that dollar bill. It's self-contained, self-verifiable, self-expressive. He doesn't have to talk to any third-party system to validate that, and it's immediately settled. But over the last few decades, when we digitized these financial systems, the assets sat on one ledger, the validation logic sat somewhere else, so on and so forth. And now all of the systems on my end, let's say that were holding US dollars, had to integrate with all the systems on Rohit's end to receive it. And that's where all of the complexity comes in. And in some cases, in most cases, that integration doesn't happen. In a few, it does in very purpose defined manners. But if you look at the more recent cryptographic advancements happening in digital signatures, etc., plus some of the work on the public chain side, it allows you to imagine a world where in a digital context, that control comes back and sort of back to the future in that sense. So that's one key aspect of the Finternet. The second aspect is when you're dealing with these diverse categories, how do you unify across them? And how do you ensure that each of these categories can have their own governance norms that are there, depending on the activity, depending on the purpose? But at the end of the day, they can come together as part of a common grid and unify such that the individual is in control of that and the individual doesn't have a splintered experience. And the third aspect was if you have to do this at humanity scale, it's very critical for universal infrastructure. And what we mean by that is if you look at many countries today, one of the big issues, or even within a country, it's the same thing is prevalent. Um, how do you get started? Many countries spend a lot of time replicating infrastructure from scratch. And that makes it really difficult for them because they'll spend 5 years building out a fast payment system. If you look at it today, of 190 countries, maybe about 20 odd have good fast payment systems that are effective that consumers can use. So everyone has to replicate this from scratch, and they build a fast payment system. Now, how do you have data sharing? You have to build a whole new other system on top of that. And then what if payments is just a stepping stone? What if you want to unlock access to your capital markets? So what we believed is that if people have to leapfrog, it's very critical that you have a minimal but common universal infrastructure. But you can regulate the flow on top of that, meaning depending on what asset is being issued, what asset is being transacted, the flow can be permissioned and controlled depending on different what we call token managers. But the fundamental infrastructure, think of it like what your app store is to your underlying smartphone abstraction, that is common. So you can control the rules on top of it, you can control what flows on top of it, but the underlying infra is common and universal. And so that was the third idea, instead of everyone rebuilding things from scratch, which is basically what we do today. And so I'll give you a quick high level overview of what this means. Um, if you look at it, really going back to my point, for us it was very core that individuals and businesses are at the core driving their own transactions. And this is important also from a legal standpoint. Our view is if you have an architecture like this, it allows you to remove a lot of the legal complexity that comes in from two systems having to integrate and the complex liability norms, etc., that get derived from that. Now, these individuals obviously can interact with a whole range of applications, and these are fundamentally what I would say unregulated. Any developer can build, plug this in. These could be applications to manage your property, cross-border, domestic payments, domestic asset transfers of different types, applications to manage investment when you're raising equity, so on and so forth. And on the left-hand side, you have essentially what we call token managers. And these are entities that issue different types of tokens. And in our view, within the Finternet, tokens are fundamentally electronic representations of different types of claims that are there. Tokens not necessarily only represent ownership. Ownership's one type of claim, but it could represent, for example, a rental agreement that you create on top of property that you own, any type of claim, or the money in your bank account, so on and so forth. And so, in many cases, you often have third-party custodians that play a role in these assets. That could be your own company when you're issuing shares. It could be third-party institutions like banks, asset managers, and so on. And so these token managers play a role in tokenizing your asset and then issuing it into a ledger of your choice that you see play out here. Apologies, the graphic seems to be refreshing from scratch, but basically the entities on the left tokenize, issue the asset into the ledger of the user's choice versus the user having to go to the ledger of one of these issuers. And that's what you see playing out, where now the user has assets issued across multiple categories on common ledger infrastructure. On the right-hand side, we have what are called value-added service providers, and these are really third-party agents that can be appended to any transaction flow uh, because you want to add additional trust. So these could be notaries, guarantors, escrow agents, so on and so forth. And unified ledgers are nothing but really maintaining state of these assets and allowing you to unlock that transactability. And we expect there to be multiple such ledgers. And uh, really, the way we look at it, and I'll just spend a few seconds on this, but I know Apoor will dive deeper. The way we look at the unified ledger layer is really, from our standpoint, we were grappling with this question. You know, you often have these consortium efforts, as some of you may be familiar, they build shared ledger infra, or you would have, you know, the work that's happening through Ethereum and other public chain communities. And we wanted to imagine, okay, how is the world going to play out? Couple of things. One, we want, we don't know the future, and since we don't know the future, the question we were saying is, can we architect and give ourselves the optionality in the present? And that's a key part of the Finternet architecture. So how do you allow for multiple chains, multiple ecosystems to plug in, and let those ecosystems to drive the evolution of that over a period of time? The second is on the public chain side. This is where what we call here as immutable proof stores. We've been thinking through because if you expect all of humanity to plug into infrastructure like this, for example, a property registrar in one country plugging in and a lender in another country lending against that asset, you need some sort of public internet-like system, right? Otherwise, you're not going to have the property registrar plug into a consortium, a closed loop private consortium. It won't happen. It won't happen at scale. So when you think of it from that standpoint, it makes a lot of sense. But obviously there needs to be some evolution that takes place when it comes to aspects of how do you have privacy by default within these transactions. How do you think about performance and scale? For context, UPI does about 500 million transactions a day. It will soon get to 1 billion transactions a day. Collectively, how do you imagine now on this infrastructure doing maybe 100 billion transactions a day, right? So how do you think about that? So the performance is the other aspect of this. And then there are a few other things. How do you have flow control, as I mentioned to you? It's not that once you issue an asset on these chains, it's just free for all. And then things also around interoperability. So there's a bunch of thinking that has already happened. I'll hand it over to Apoor to talk about it and double click on that and run you through some demos. But thank you all again for your time, and excited to see how this plays out.
Thank you, Siddhant. Fun fact: he's actually in Boston right now, so it's 4 a.m. for him. So thanks for coming across and doing this demo. And
Yeah, to really use my coffee to stay up.
awesome, cool. So I think hopefully I can take it from here. So what I can do is I can share these slides. Yeah. So leaving from where Siddhant left off, this is a high overview of like how the Finternet architecture looks like. And for people who are in the Ethereum ecosystem, a good way to think about these is like app chains. So right, the unified ledger or the Finternet ecosystem has some terminologies, but a lot of these terminologies can be mapped to things that we're already saying and doing in the Ethereum ecosystem. I won't be going very, very deep into this in the architecture side, but like obviously we are here and happy to discuss this after this session. But essentially what we're calling unified ledgers over here in the Finternet can be thought of as app chains. This could be your base app chain, it could be an HDFC app chain, it could be some other app chain, right? Anybody can spin up their own app chain. We call it a unified ledger. And the reason it's a unified ledger is because the Finternet protocol itself is going to specify a spec for all these app chains to communicate each other, right? So the idea is that how do we, like something like the email, like how do we come up with a protocol where like whether you're using Gmail or Hotmail, it doesn't matter, you can still send emails to each other. So how do we come up with this spec so that, like even if there are like tens of app chains that are following the Finternet spec, that are part of the Finternet spec, they can still talk to each other. So our job over here, and this Finternet side, when you're deciding this architectures, what interfaces do we come up with and what are the sort of design choices that we do so that we are flexible enough, but at the same time we're like secure enough and like people can actually, like real life use cases can actually happen over here, right? So if I just had to like quickly go through this, it would be like our API layer is like JSON RPC that you already have in Ethereum. Everyone has storages, your full nodes, your sequencers, they store something, they have a runtime, whether it is Solana, EVM, Cairo. You have an authorization layer that decides how your private key is validated, or if you have account abstraction that's like more generalized. But high level overview is like this is how the unified ledger looks like. An important component is the ILP over there. The ILP is essentially for interledger communication. So how can two ledgers talk to each other in a safe way? So that is a general overview of the architecture. I won't go more deep right now, but like I said, like happy to discuss this after that, like after the session. But my main job right now over here is to give an example of what can actually happen on Finternet, right? So that we can actually feel the power of the use cases that can come up if we get this right. So a few use cases that are actually being worked upon actively in the Finternet group right now is there is a FX transfer use case on how do you do cross-currency transfers. There is a use case around real estate tokenization. So how do you get real estate on chain? And you can take loans for it, loans against it, mortgage, and like all those things happen through rules that have been like dictated or decided on chain. And there's also a use case around energy and climate, for example, like tracking of carbon credits, or like how do you track energy consumption on chain in a transparent way. So these are like 3 use cases that are being actively worked on in the Finternet group today, which is free for anyone to join. You can just go to finternetlab.io, join Discord, and you can follow conversations. But one use case that I want to like go deeper right now is the Forex transfer use case to show what happens today and what can happen if we can get Finternet, like if we can make Finternet happen, right? So there's an amazing paper written by Sheikh, who's over here, and Suraj from Dive on how Finternet can come and make FX transfers better. So what we actually went ahead and did is try to create an implementation based on this paper. Before we get to that implementation, let's have a quick explain like I'm of how Swift transfers work today. So let's take a basic example. I'm in India, I have 100 INR, and I want to send my friend who's in Singapore, I want to send him some like Singapore dollars, right? How it works today in a very basic way is that I'm going to give the INR, I'm going to tell my Indian bank that, hey, I want to transfer some money. They will deduct the money from my account. And then my Indian bank account needs to have equivalent amount of Singapore like dollars on the other side in Singapore so that it can continue that transfer and send it to my friend, right? So I tell my bank I want to send 100 rupees to my friend in Singapore. So they'll deduct my 100 rupees here. They'll go to the bank in Singapore and they'll reduce, like they'll take the monies, the Singapore dollars that the bank had. They'll use that to complete the transfer on the other side. And this is not happening in real time. How this happens is like I'll do this transfer today, and hundreds of transfers will happen over this week, and then you will have T plus end settlement times where you have clearing houses and all these people come together, they'll check the ledgers and they'll just close the books. So it's a fairly complicated process, a lot of manual labor, a lot of manual things involved, which is also why you see SWIFT transfers or like all these international transfers being expensive. So a key point to here is that no money is being moved in real time. It's just a SWIFT is just like a message which is saying that, hey, there is a transfer. So whatever money you have, deduct it right now from there and complete it, please, and we'll settle it like in T plus N. That's what's happening today. And how we can potentially solve this with the Finternet is if we can convince people or convince these institutions to come on a unified ledger, basically a publicly verifiable ledger, that anyone can verify, all these institutions can verify, and we can somehow ensure that like everyone who's using it is using it in a compliant way. We don't want people like non-KYC users coming across. We don't want people to probably, we want to have checks if it's over $1 billion. These are the checks that have to pass. If it's just $1, it's okay if there is no specific check passing, right? How do we encode all these checks so that all the banks are happy that, hey, okay, this is verifiable. I can see the checks are passing, so I'm okay to tokenize INR on this chain, or I'm okay to tokenize Singapore dollars on this chain. That is the idea of Finternet. This obviously leads to faster settlements, faster tech, very low fees in general. And now I'll try to show a quick demo that we tried to spin up over the last few days. So over here, I'm logged in right now. Like I'm quickly creating a Finternet ID in this ecosystem. So think of it like an ENS domain maybe. So let's say I do Apurva 7. So I will sign up here and I will claim a Finternet ID for myself. Okay, I think, Hopefully the demo gods are here with me today. I have a video just in case things don't go correctly. Okay, all right. So I'm signing up. You can ignore the error message for now. It's saying that it's not able to simulate it. By the way, everything happening here right now is a unified ledger that we have spun up that's actually settling on Ethereum. It's actually a chain that we have spun up for this specific Forex transfer use case. So I'm going to confirm this transaction, and I'm going to claim Apurv S77. I'm going to quickly do a KYC. I'm not sure how much is visible, actually. Maybe I'll zoom in. But yeah, currently for this demo purposes, that KYC is like, it's hacky. You can enter anything you want. In reality, you will have someone submit the hash of your document, or maybe something like Anon-Aadhaar, where you submit a ZK proof of your Aadhaar on-chain, and it gets verified, and you know that this user is now KYC'd, right? So on-chain, Apurv is now KYC'd. And this is how my portal looks like, since I've already been demoing this all day. You can see I already have 5.5K INR and $300 in Singapore dollars. But quickly, let me go to the bank portal, right? This is what the bank sees. Bank sees that, hey, Mehul isn't KYC'd, he hasn't completed his KYC, so I'm not able to tokenize anything for Mehul today. But since Apurv has completed his KYC, let me tokenize and issue his money, which he has in the bank on-chain, so he can actually use it for different purposes, right? So as a bank, I'm go to my dashboard and I'll be like, I'm gonna, like, this is what we call the token manager in some way in the Finternet. So if you read the paper, if you're seeing token manager, this is the job that he takes. He decides that I'll tokenize assets for someone on-chain. So if I go back, I had around 5K, so I should have, yeah, I have 6.5K INR on-chain right now, which I can use. So now, let's say, you know, like, I try to submit to Mehul. I try to send him like 100 INR. But we saw that Mehul isn't KYC'd, right? So this shouldn't work. My chain or my infra shouldn't allow this transfer to take place. And as you can see, it says KYC not approved. So on-chain, this check is happening, which is saying that this user doesn't have a valid KYC, so you cannot do this FX transfer. So it's a very basic example of how you can bring compliance on-chain. And if I, let's suppose, you know, like if I just transfer it to myself for a minute, ideally this should work. And yeah. So now, my balance would reduce by 100 over here, and yes, from 300, my Singapore dollars went to 400. So this is how you can do a basic Forex transfer use case on-chain, settling live on Ethereum. Yeah, so with that, I will give it to Rohit, who will talk about how and where Ethereum as a ecosystem or as a chain aligns with the Finternet.
Yeah, thanks, Apu. So as you saw, like everything that happened here was on Ethereum. It was using an app chain, if I understand the Starknet architecture right. So where does Ethereum come into the picture? So first of all, Finternet is generic, like as Siddharth told, like it does not care about what chains will evolve tomorrow, how Ethereum will change, how Solana will change, or if some new public blockchains will come, or if somebody want to use private blockchains. So Ethereum as a philosophy is neutral to all of that. The core philosophy is we want to enable where you can permission the flows. Whenever you are doing the transactions, you can permission those flows, but you can use permissionless settlements. So what we saw just in the demo, like KYC was blocked when you were initiating the transfer. Once the transaction was done, it was settled on the Ethereum. That's the core philosophy of Finternet. Like it allows it to be generic. It doesn't allow it to be opinionated about any technology. Now, where does Ethereum fit into that vision? I think Ethereum has already designed its architecture in a way which lets you enable your own runtime, your own layer 2s. What are layer 2s? We continuously criticize layer 2s, like they are centralized, they are single sequences. But if you think about it, that's what permission means. So you can create layer 2s for carbon-specific use cases. Maybe HDFC can spin up a layer 2 where they define like what kind of permissions, what kind of permission flows they want to execute within their, you can say like the layer 2 architecture, and then they're ultimately using Ethereum to communicate with someone, some bank in the Singapore. Like, so these two banks are able to communicate via Ethereum, but within their own system, like they are putting up, making sure like they are doing all the compliances or they are doing all the permission checks that they want to do. So these are two links, by the way, like where Sheikh is here and like Apur is here, like all these guys have put together a lot of documentation, a lot of explanation around a lot of terminologies that we have used. So definitely like scan this. I'll come back to the slide again if you want to scan. But like today what we want to do is, so what we just saw in case of the money transfer flow, from the technological perspective now it works, just from the transaction perspective. But it doesn't work in practice. The reason for that is we still don't know what KYC meant in that case. Like, yes, you created a hash of some data, but if I am sending money to someone in Singapore, how does the Singapore bank knows that this money was sent by someone in India, that person was KYC'd, or who ensures like this person was KYC'd? If Indian government, let's say, go back to this bank, like how did you let this transaction go through? I think this transaction was for money laundering. How do they catch this person and put him in jail or like put whatever fines? So they need sometimes access to raw data as well. So that means like proofs are not as simple as just ZK proofs. It comes with the angle of I am putting some data which could be like encrypted form of KYC. So there is raw data. This raw data could be accessible by specific participants. It could be the person whom I'm sending money to. Only these two people need to know how much I sent, how much, who sent the money to me, but nobody else needs to know in the world. So it's selective revealing of the data. So how do we make sure of that? At the same time, you are making sure the Singapore bank is able to say, like, yes, this transaction came through all the compliances from the Indian jurisdiction perspective, as well as from the Singaporean jurisdiction perspective. At the same time, a policy maker like need to know, okay, like, how do I know like this KYC check was done well? Like HDFC can do the KYC. There can be a business who can do the KYC. How do I know they followed the certain standard to do this KYC? So keeping those problem statement in mind, like we put together some 5 or 6 elements like which we are struggling with today, which we wanna jam about now. Like this is gonna be a very open-end conversation like just here. These are the problem statement like proof of portability. So as we saw, there were different token managers. So how does the proof move from one token manager to another token manager without revealing like any private data of the user? Similarly, how do you allow auditor to access raw KYC data if needed, like in certain scenarios? It could also be like, maybe you don't wanna also enable the policymakers to like just access data of everyone like just however they want. You wanna put some kind of conditions that is also auditable. Like this is the reason we asked for raw data of this particular user. You wanna leave those footprints. Similarly, proof of execution. So like in that case, you were sending 1,000 INR and you were getting 200 SGD. How do you know you got the best price? So like there is a, by the way, in that example, there is a whole intent solver network in the backend. So how do you make sure like the execution was done correctly? That's where like all the things we have been already doing in Ethereum. Similarly, like proof of data availability in the context of KYC, that, okay, like I did proof of address verification, I did proof of identity verification. So how do we know somebody is storing that data somewhere? Maybe we keep the raw data at IPFS in some encrypted form, but we still need to convince someone like this data exists, that there is availability of this data. Like it can't be like you have done it once and now there is no way to retrieve that data. Similarly, like as I said, selective data access from the proof to certain parties. So this is what we want to discuss today now. I'll just leave the previous slide if anyone wanna like scan this. But now we are gonna just chat in this room and just discuss about these topics. Yeah, thanks everyone. So whoever wanna stay for the jam session, like we'll just do it here. Just come in the front. Anyone who thinks like it's not relevant for you, like feel free to like just leave the room.